Hello everyone, you are welcome to this video. I remain your tutor life changer. This is the part 5 series on solving waec questions on the periodic table. Okay, so this one says consider the following atoms. We have XRT and and XST. Whenever you see things like this, of course you know these are isotopes, right? Okay, the atomic number is always the same, which is T, and the mass number is different. Now, the first one says, state the phenomenon exhibited by these two atoms. The phenomenon is called isotopy. Okay? What is the difference between the two atoms? The difference is their mass numbers. The difference is their mass number, or you can even say number of nucleons. Of neutrons, sorry. Okay, that is what differentiates them. Now give two examples of elements that exhibit this phenomenon. There are many of them. Chlorine is one of them. Chlorine, we have chlorine 35 and we have chlorine 37. Okay. Even oxygen, we have oxygen 16, oxygen 17, oxygen 18. And even hydrogen, we have hydrogen 1. We have hydrogen 1, hydrogen 2, and hydrogen 3. There are many of them. In fact, almost all elements exhibit this phenomenon. Now the next one says if T is 17, okay, that's the atomic number, write the electron configuration for the element. 17 means that it's going to be 1s2. In configuration you have 1s, after 1s is 2s, after 2s is 2p, after 2p is 3s, after 3s is 3p. Let's stop here for now. S cannot take more than 2 electrons, P cannot take more than 6 electrons. So the first two here, 2s2, that makes it 4. 2p6, 4 plus 6, that makes it 10. 3s cannot take more than 2, so 2. 10 plus 2, that's 12. And this is 17, so that means here has to be 5. So this is the answer. This is the electron configuration for T. And obviously that element is chlorine. Now the next one says state two differences between metals and non-metals with respect to their physical properties and their chemical properties. Okay, between metals and non-metals. Okay, number one is that metals are usually solids at room temperature. That's one of the ways you can differentiate them. But non-metals are usually gases and liquids at room temperature. We have some non-metallic solids, but majorly are gases and liquids. Another difference again is that metals are sonorous. They make sonorous sounds, but you can't say that of non-metals. That's another difference in their physical property. Another difference is that metals are ductile. You can draw them into sheets, but that's not the same with non-metals. Another difference is that metals are malleable, but non-metals are not malleable. There are many examples. Okay. Then the next one says chemical properties. So the difference between the chemical properties of metals and non-metals. Okay. Okay, let me say with oxygen. Let me start with reaction with oxygen because both of them react with oxygen. But the difference is that metals react with oxygen to form basic oxides. It's either basic oxides or what we call and also amphoteric oxides. Okay, so for example, you can have let's say magnesium plus oxygen. If magnesium bonds in oxygen, you're going to get magnesium oxide like this. Okay, this is a basic oxide. And another reaction, let's say zinc can also react with oxygen to form zinc oxide, and zinc oxide is an example of an amphoteric oxide. Okay, that's for us to note. Now, but in the case of non-metals react with oxygen to form acidic oxide or neutral oxide. So it's either it forms acidic oxide or it forms neutral oxide. Okay, so an example is something like carbon is a non-metal. When it reacts with oxygen, you are going to get CO2. This is an acidic oxide. Okay, and you can also, nitrogen plus oxygen can give us NO. This one here is a neutral oxide. Let me take this up. So this is neutral oxide. So that's one of the difference in their chemical properties. Another difference in their chemical properties is that um, metals react with hydrogen to liberate, react with water to liberate hydrogen. But that's not the case with non-metals. Non-metals do not liberate hydrogen. A good example is if I have magnesium plus water, magnesium reacts with steam to form magnesium oxide then plus hydrogen. All metals displace hydrogen, or will I say produces hydrogen on reaction with water. But that's not the same thing with non-metals. As a matter of fact, non-metals, not many of them react with water. Yeah, not many of them react with water. They don't really have any special reaction with water. Another difference again is that metals can react with acids, to liberate hydrogen gas, but non-metals do not behave that way. Metals like zinc, for example, can react with H2SO4 to liberate hydrogen gas. So you have zinc sulfate, then plus hydrogen gas, and that goes. That these are very very important things for us to note about the differences in the chemical properties of metals and non-metals. Okay. Now the next one says, give one example of each of the following compound. Number one, amphoteric oxide. Aluminium oxide is amphoteric, zinc oxide is amphoteric. There are many of them like that. They are amphoteric oxides. Okay, so the other one says a hydride which evolves hydrogen when reacted with water. A hydride which is only metallic hydride that can evolve hydrogen when react with water. When I say metallic hydrides, like sodium hydride, so when you have sodium hydride plus water like this, you're definitely going to get sodium hydroxide and hydrogen gas will be liberated. This is a property of hydride. And for those of you that don't know what hydrides are formed only whenever hydrogen is combined with a metal. Okay, so the valency of hydrogen is always +1, but anytime hydrogen combines with a metal, the valency becomes -1. That's when it becomes a hydride. So you can have sodium hydride, you can have calcium hydride, and one of the properties of hydride is that they react with water, to liberate hydrogen. I want you to note that. That's very important. Then the third one says a triisocarbonate 4 which is readily decomposed on heating. Now let me say this, apart from sodium carbonate and potassium carbonate, all other carbonate decompose on heating. Please find my lectures on reactions of types of reactions. I did a very good job here on types of reactions. So triisocarbonate, so any other carbonate decompose on heating, like calcium carbonate does, zinc carbonate does, magnesium carbonate does. All other carbonate decompose except sodium carbonate and potassium carbonate. Very important, please. Now the next one says a chloride salt which is readily hydrolyzed in water. A chloride salt which is readily hydrolyzed in water. There is no other salt that can come to your mind than sodium chloride. Can easily be hydrolyzed in water, can easily be separated by water, and all of that. So sodium chloride is one of the most soluble salts. You can say sodium chloride, you can say potassium chloride. Okay, the C here says Ci. State the 3 characteristics of properties of transition metals. Very easy. Transition metals are very wonderful and has certain properties. Number one, that they are paramagnetic. That means that they can be influenced or attracted by a magnet. That's one of them. Secondly, okay, maybe I should write this down. Paramagnetic. P-A-R-A, magnetic. Okay, that's the first one. Secondly is that they have many oxidation states. Okay, we can write there multiple oxidation states. Okay, that's the second one. Multiple oxidation states. They have many oxidation states. That's the second one. Then the third one is that another wonderful property is that they form colored salts. They form colored salts. So transition elements actually form colored salts, transition metals. and they also form complex salts. Okay, transition metals have the ability to form complex salts. That means they can combine with, other species using coordinate covalent bond. Okay, that's another special property of transition metals. I'm thinking to see if there is any other that comes to mind apart from these ones. Of course, they have incomplete, they are d orbitals, they have incomplete d orbitals, incomplete d orbitals. Okay, that's another one that differentiates them. Okay, for now, these are the ones that comes to mind. If I remember any other, I will let you know. And then the II says write the electronic configuration of zinc. Okay, well, zinc is the 30th element, that's number 30, the last in the periodic table. And the configuration, I can say argon, I can put this argon, then say argon is 18, so this will now be 3d10, which is 28, then 4s2, which is this. Okay, or you can simply write the configuration for argon, which is 1s2, 2s2, 2p6, 3s2, 3p6, which is argon, which is 18. 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18. Then you can now add it up with 3d10 and 4s2. Now, I want to say this. This is the configuration for zinc. Whether you write this or you write this, you are correct. Now, but I like to say this, that have you noticed something, that all the orbitals of zinc are completely filled? For example, the 4s, all of them are filled. 4s2, 3d10, all of them are completely filled. That is the reason why most times zinc is not necessarily seen as a transition element, even though it falls in a transition element category. For example, zinc, the color of zinc is white. Zinc is white in color, instead of others that are colored, have different colors, but zinc is white. Why? Because the orbitals are completely filled. Okay, that's an exam question, so I just added that because I know it's going to help somebody. So thank you very much. See you in my next video.